Okay, my name is Julia Cornwell, and we are going to talk about Ohm's law. Ohm's law is pretty simple, really. It is represented in an equation by V equals IR. So V represents the voltage, which is also measured in volts, and that's equal to I, which represents current, measured in amperes, times resistance, which is measured in ohms. We see from this equation that I, or the current, is directly proportional to the voltage, and that I is indirectly proportional to resistance. So in other words, when the current goes up, so does the voltage, but if the current goes up, then the resistance would go down. So we are going to demonstrate this by looking at some examples of skiing. We're going to pretend that me as the skier, I'm going to be an example of current. I'm like an electron trying to flow through a wire, and the snow is the wire, and it has its own resistance that will control my speed. So we'll watch this first video. Okay, pretty quick, but it just shows me moving through the wire, essentially. And now we're going to say that it's been really cold, and so the ground is pretty icy, and that provides less resistance. So what's going to happen to me as a current when there's less resistance? So even shorter because I moved really fast. So because the resistance had gone down, the current was higher. So in other words, in this example, there were more skiers that would have been able to pass through the same area in the same amount of time because we were moving faster. So higher current, less resistance. So now let's say it's been snowing a lot, there's a lot of powder on the ground, and that provides more resistance. Then what will happen to my speed as a skier? Okay, so obviously I moved a lot slower in that one. So therefore, theoretically, less skiers would be able to move through the same area in the same amount of time because I was going slower. So this translates to current moving slower because there's a higher resistance. So now I'll go through a more physics-related example. Here we have a simple circuit drawn to our right, and the question is, what is the resistance of an automobile headlight through which 3 amps flow when 12 volts is applied to it? So we have 12 volts coming from here, flowing as current, and it's going to flow through this resistor right here. And so we're trying to find out what this resistance is. So it's a really simple problem because we're just going to use our equation, V equals IR, and plug in our volts and our amps, and with the math we'll find out that resistance is 4 ohms. So that's a pretty basic problem, but we can make it more complicated as circuits get bigger, but this is always going to be the underlying principle of it. There are a couple of factors that will affect your resistivity. That can be the shape of the wire or whatever conductor you have, and also the material it's made of. So for example, in our skiing example, different skis will have slightly different resistances depending on what they're made of and what shape they are. And that will affect how fast people go and the kind of control that you have while you're skiing. So in summary today, Ohm's law basically just describes a relationship between voltage, current, and resistance. This is a picture of George Ohm, who discovered Ohm's law or wrote Ohm's law back in the 1800s. And so with this, we can learn more about our electrical world and circuits and how to use them. Thanks.